biggest galaxy we have ever discovered is so large that your brain will struggle to truly understand it. This is not an exaggeration. This is not dramatic storytelling. This is the honest truth about a cosmic monster that sits over 1 billion light-years away from us, quietly existing in the darkness of space, holding more stars than you could ever count in 1 million lifetimes. If you are anything like me, you probably thought you understood how big things could get in space. You have seen the pictures of Jupiter dwarfing Earth. You have heard how our Sun could fit 1 million Earths inside of it. You might have even wrapped your head around the fact that our Milky Way galaxy stretches across 100,000 light-years from one side to the other. But all of that, every single comparison you have ever heard, becomes almost meaningless when you learn about what astronomers found hiding in a distant corner of the universe. If you enjoy learning about the strangest and most mind-bending things in our cosmos, please take a moment to like this video and subscribe to the channel. It helps us bring more content like this to you, and it lets us know that you want to keep exploring the universe together. Now, let me set the stage for you. Our home, the Milky Way, is what scientists call a barred spiral galaxy. It has beautiful curving arms made of stars, gas and dust, all swirling around a central bulge where an enormous black hole sits. From one edge to the other, our galaxy measures roughly 100,000 light-years across. That means if you could somehow travel at the speed of light, which is the fastest anything can move in our universe, it would still take you 100,000 years to cross from one side of our galaxy to the other. That is already almost impossible to truly grasp. 100,000 years is longer than modern humans have existed. It is longer than the time since we first learned to paint on cave walls, longer than every civilization that has ever risen and fallen on Earth combined. And yet that is just the width of our own little corner of the cosmos. The Milky Way is home to somewhere between 200 billion and 400 billion stars. Each of those stars might have planets orbiting around them, moons circling those planets, is asteroids tumbling through space and comets streaking through the void. Our Sun is just one of those hundreds of billions of stars sitting about 26,000 light-years from the galactic center in a quiet neighborhood called the Orion Arm. Our Sun and its family of planets orbit the center of the galaxy at a speed of about 500,000 mph. Even at that tremendous velocity, it takes our solar system about 250 million years to complete a single lap around the galactic center. Astronomers sometimes call this period a cosmic year or a galactic year. In the entire time that dinosaurs roamed the Earth, our solar system did not even complete one full orbit. The last time our Sun was in roughly this position in the galaxy. The most complex life on Earth was simple marine organisms. That is how vast even our own galaxy is. The space between stars in the Milky Way is almost unimaginably empty. Our nearest stellar neighbour, a small red dwarf called Proxima Centauri, is about 4¼ light-years away. That distance is so great that if you shrunk the Sun down to the size of a grain of sand, Proxima Centauri would be another grain of sand sitting about 4 miles away. The space in between would be essentially void, just the faintest whiff of gas and dust and the occasional particle of cosmic radiation. This emptiness is hard to wrap your mind around. We live on a crowded planet surrounded by billions of other people sharing space with countless other living things. We are used to density, to things being close together, to the world being full. But step outside our solar system and emptiness becomes the rule. Stars are separated by such vast gulfs that the chance of any two of them colliding by accident is essentially zero. Galaxies can pass through each other without any stars actually hitting one another. Yet somehow, even in all that emptiness, there is enough stuff out there to make hundreds of billions of stars in our galaxy alone. The gas and dust between stars may be sparse, but spread across thousands of light-years. It adds up to enormous amounts of material. New stars are forming right now in giant molecular clouds scattered throughout the Milky Way, places where gravity has pulled enough gas together for nuclear fusion to ignite. Our galaxy is alive with stellar birth, even as old stars burn out and die. When you look up at the night sky from a dark location, that hazy band of light stretching overhead is actually the combined glow of billions upon billions of distant stars in our own galaxy. Ancient people thought it looked like spilled milk across the heavens, which is where the name Milky Way comes from. For most of human history, we assumed that was everything. We thought our galaxy was the entire universe. Different cultures had different explanations for that band of light. The ancient Greeks told stories of milk spilled from the goddess Hera's breast. The Romans called it the Via Lacta, the Milky Road. In India, it was seen as the past souls take on their journey to the afterlife. Aboriginal Australians saw it as a river in the sky. People throughout history have looked up at that same band of light and wondered what it might be. When the first telescopes were turned toward the Milky Way in the 17th century, observers began to realise that the milky glow resolved into countless individual stars, too faint and too numerous to see with the naked eye, but visible through the magnifying power of glass lenses. This was the first hint that our galaxy was far larger and contained far more stars than anyone had imagined. It was not until the 1920s that an astronomer named Edwin Hubble proved that those fuzzy smudges people had been seeing through telescopes were actually entire galaxies themselves. Each one containing billions of their own stars, each one impossibly far away from us. That discovery changed everything we thought we knew about our place in the cosmos. Hubble made this discovery at the Mount Wilson Observatory in California, using what was then the largest telescope in the world, a reflector with a mirror 100 in across. He was observing a class of stars called Cepheid variables in what was then called the Andromeda Nebula. These stars pulse in brightness with a regular period, and by measuring their apparent brightness and pulsation rate, Hubble could calculate how far away they were. The result was shocking. The Andromeda Nebula was not a cloud of gas within our own galaxy, as many astronomers had assumed. It was roughly 1 million light-years away, far beyond the edges of the Milky Way. It was an entirely separate galaxy, an island universe of stars in its own right. Our galaxy was not the whole cosmos. It was just one galaxy among many. We now know that Hubble's original distance estimate was off by about a factor of 2. The Andromeda Galaxy is actually about 2 million light-years away, not 1 million. But the basic conclusion was correct. The universe was vastly larger than anyone had imagined, filled with countless galaxies, each containing billions of stars. Today, we estimate that there are around 2 trillion galaxies in the observable universe. 2 trillion, that is a 2 followed by 12 zeros. Each of those galaxies contains billions or even trillions of stars. The numbers become so large that they stop meaning to our human brains. But here is what makes this story interesting. Not all galaxies are created equal. Some are tiny dwarf galaxies with just a few billion stars. Others are massive spirals like our Milky Way or our nearest large neighbour, the Andromeda Galaxy. And then, sitting at the extreme end of the scale, there are the true monsters of the universe. Galaxies so enormous that they make our Milky Way look like nothing more than a speck of dust floating in an empty warehouse. Galaxies come in many shapes and sizes. The most common type in the nearby universe are spiral galaxies like our own, with their distinctive pinwheel arms and flat rotating disks. These galaxies are typically sites of active star formation, with new stars being born in the gas-rich spiral arms. The beautiful structure we see is maintained by a balance between the rotational motion of the disk and the gravitational pull of all the matter within. Elliptical galaxies are another major type. Unlike spirals, these galaxies have no particular structure. They range from nearly spherical to highly elongated oval shapes, and they are populated mainly by old red stars. Star formation in elliptical galaxies has largely ceased as they have exhausted most of their gas supply. The largest galaxies in the universe are almost all elliptical, formed through the merger of multiple smaller galaxies over billions of years. There are also irregular galaxies which have no defined shape at all. These are often the result of gravitational interactions with nearby galaxies, which have pulled and distorted their structures. The melanic clouds visible from the southern hemisphere are examples of irregular galaxies that are being affected by the Milky Way's gravity. Galaxies are not distributed randomly through space. They are organized into larger structures. Galaxy groups contain a handful to a few dozen galaxies. Our own Milky Way belongs to the local group, which contains about 80 known galaxies, including Andromeda, and several dozen dwarf galaxies. Galaxy clusters are larger, still containing hundreds to thousands of galaxies bound together by gravity. And the largest structures of all are superclusters, vast assemblages of galaxy clusters stretching across hundreds of millions of light years. The galaxy I want to tell you about today is one of those monsters. It goes by the somewhat boring name of IC 1101, which comes from its entry number in a catalogue of celestial objects created over a century ago. But do not let the dull name fool you. There is nothing boring about this cosmic giant. IC 1101 sits at the centre of a cluster of galaxies called Abell 2029, located in the direction of the constellation Virgo, as seen from Earth. When astronomers point their telescopes toward this region of the sky, they see a massive collection of galaxies, all bound together by gravity dancing around a common centre. And right in the heart of that cluster, dominating everything around it, like a cosmic emperor on a throne, sits IC 1101. This galaxy is estimated to be somewhere around 4 to 6 million light-year across. Let that sink in for a moment. Our Milky Way, which already seemed impossibly large, is only about 100,000 light-year wide. IC 1101 is roughly 40 to 60 times larger than our entire galaxy. If you placed IC 1101 where our Milky Way currently sits, it would not just engulf our galaxy. It would swallow our entire cosmic neighbourhood. The Andromeda galaxy, which is about 2 million light-years away from us, would find itself inside IC 1101's massive body. The Triangulum galaxy, another neighbour of ours, would to be consumed as well. All of the dozens of smaller dwarf galaxies that orbit around us, places like the large Melanic Cloud and the small Melanic Cloud, would simply become tiny components of this giant's vast structure. But size is just the beginning of what makes IC 1101 so incredible. This galaxy is estimated to contain around 100 trillion stars. 100 trillion. Our Milky Way has maybe 400 billion stars at most. That means IC 1101 has roughly 250 times more stars than our home galaxy. If you started counting stars in IC 11 1 star per second without stopping, it would take you over 3 million years just to count to 100 trillion. And that is assuming you never slept, never ate, never took a break of any kind. The story of how we discovered this cosmic giant begins back in 1790, when a German-born British astronomer named William Herschel was systematically scanning the night sky with his telescope. Herschel was one of the greatest astronomers of his era. He had already discovered the planet Uranus several years earlier, and he spent much of his life cataloguing thousands of celestial objects that no one had ever documented before. On June the 19th of that year, Herschel pointed his telescope toward a region of sky in the constellation Virgo and noticed a faint, fuzzy blob of light. He carefully recorded its position and moved on to the next object. At the time, Herschel had no way of knowing what he was actually looking at. The technology did not exist to measure how far away this object was. The scientific understanding did not exist to recognize that it was an entire galaxy separate from our own. Herschel simply logged it as another nebula, one of many mysterious cloud-like objects scattered across the heavens. For over a century, that faint smudge of light remained a mystery. It was eventually given the designation IC 1101 when it was included in a catalogue called the Index Catalogue, which was an expansion of an earlier list of celestial objects. Astronomers studied it when they could, but without the tools to understand its true nature, it remained just another entry in a long list of cosmic curiosities. Everything changed in the 20th century when astronomers developed better telescopes and new techniques for measuring cosmic distances. They discovered that IC 1101 was not a cloud of gas within our own galaxy. It was an entirely separate galaxy, mind-bogglingly far away. The light we see from IC 1101 today left that galaxy over 1 billion years ago. It has been travelling through the void of space for more than 1 billion years just to reach our telescopes. When that light began its journey towards us, life on Earth was still mostly single-celled organisms. Complex animals had not yet evolved. The dinosaurs would not appear for another several 100 million years. Every major event in human history, from the first civilizations to the invention of the telescope itself, happened while that ancient light was still crossing the emptiness between galaxies. As astronomers continued to study IC 1101, they began to understand why it was so incredibly massive. This galaxy did not grow to its enormous size through normal processes alone. It became a giant through an act of cosmic violence that has been happening for billions of years. IC 1101 is what scientists call a cannibal galaxy. It has been eating other galaxies. To understand galactic cannibalism, you need to think about how gravity works on the largest scales. Galaxies do not exist in isolation. They are grouped together in clusters, held together by their mutual gravitational attraction. Within these clusters, galaxies move around each other, sometimes passing close by, sometimes colliding directly. When two galaxies get close to each other, their gravity begins to distort their shapes. Stars get pulled out of their normal orbits. Gas and dust get compressed and stretched. If the galaxies are similar in size, they might merge together over hundreds of millions of years, eventually forming a single larger galaxy. But if one galaxy is much bigger than the other, something different happens. The larger galaxy simply absorbs the smaller one, stripping away its stars and gas, adding all of that material to its own massive body. This is what has been happening to IC 1101 for billions of years. As the largest and most massive galaxy in its cluster, IC 1101 sits at the gravitational center of everything around it. Smaller galaxies that venture too close get trapped by its enormous gravity. They spiral inward, getting torn apart and consumed over millions of years. Each meal makes IC 1101 a little bit bigger, a little bit more massive, a little bit more dominant. Scientists estimate that IC 1101 has undergone at least 76 major mergers over its long history. 76 times another substantial galaxy fell into this cosmic giant and was absorbed into its body. And those are just the major mergers. Countless smaller dwarf galaxies have also been consumed. Galaxies so small that they barely registered as a meal for this enormous predator. The evidence for this cannibalistic history is written in IC 1101's very structure. When you look at a galaxy like our Milky Way, you see a beautiful spiral pattern. Those spiral arms are regions where stars are actively forming, where clouds of gas are collapsing under gravity to create new stellar nurseries. Spiral galaxies have lots of gas and dust, the raw materials needed for star formation, and they have a distinct rotating disk shape. IC 1101 looks nothing like this. It is what astronomers call an elliptical galaxy, which means it has a smooth, oval-shaped appearance with no spiral arms at all. Elliptical galaxies form when spiral galaxies merge together. The violent gravitational interactions during a merger destroy the delicate spiral structure, mixing all the stars together into a more random spherical or oval distribution. The fact that IC 1101 is an elliptical galaxy tells us that it has experienced so many merges that any original spiral structure it might have had has been completely erased. All of those collisions, all of that gravitational chaos has stirred up the stars like someone mixing ingredients in a cosmic bowl. What remains is this smooth, featureless giant, a testament to billions of years of galactic consumption. But there is something even more remarkable about IC 1101. Despite containing 100 trillion stars, it is actually a dying galaxy. The stars within it are almost all old. Most of them are what astronomers call red giants or yellow stars, ancient stellar objects that have already burned through most of their fuel. Very few new stars are being born inside IC 1101. This might seem strange at first, with so many stars and so much mass. You might expect IC 1101 to be a hotbed of stellar activity, but remember how it grew so large. Every time I consumed another galaxy, it also consumed that galaxy's gas supply. Gas is the fuel for star formation. Without gas, new stars cannot be born. Over billions of years of cannibalism, IC 1101 has used up or expelled most of its available gas. The mergers themselves were often violent enough to heat the gas to extreme temperatures, making it expand and escape the galaxy entirely, or to compress it so quickly that it all formed into stars at once in brief, intense bursts of activity. Either way, the end result is a galaxy that has run out of raw material. What remains is a quiet giant slowly fading into the cosmic night. The stars that exist now will continue to shine for billions of years to come. But as they eventually burn out and die, there will be no new generations to replace them. IC 1101 is like an ancient kingdom that has conquered all of its neighbours but has no children to carry on its legacy. It is massive, powerful and utterly magnificent. But it is also approaching the end of its active life. At the very heart of OC 1101 lies something even more incredible than the galaxy itself. Sitting at the centre of this cosmic giant is one of the largest known supermassive black holes in the entire universe. Every large galaxy has a supermassive black hole at its core. Our own Milky Way has one called Sagittarius, a star which contains about 4 million times the mass of our Sun. The black hole at the centre of the Andromeda galaxy is even bigger, containing somewhere around 100 million to 200 million solar masses. But the black hole at the centre of ICU 1101 is in a completely different category. Scientists estimate that it contains somewhere between 40 billion and 100 billion times the mass of our Sun. To put that in perspective, this single black hole might have 25,000 times more mass than the black hole at the centre of our entire Milky Way galaxy. The largest galaxy ever discovered is so vast that the human brain simply refuses to fully process its size. This is not poetic exaggeration or cinematic drama. It is the raw, unsettling truth about a cosmic titan located more than 1 billion light-years away, silently drifting through the darkness, containing more stars than any mind could count across millions of lifetimes. Most of us believe we already understand how big the universe can be. We've seen diagrams of Jupiter towering over Earth. We've heard that more than 1 million Earths could fit inside our Sun. We've learned that the Milky Way stretches around 100,000 light-years from end to end. These numbers sound impressive until they are suddenly rendered meaningless. Because everything you thought you knew about cosmic scale collapses the moment astronomers uncovered what was hiding in a distant corner of the universe. Before we reach that discovery, we need to understand where we live, our home galaxy. The Milky Way is a barred spiral galaxy, a vast rotating disk of stars, gas and dust, wrapped around a dense central bulge. At its heart lies a supermassive black hole quietly anchoring everything in place. The Milky Way spans roughly 100,000 light-years. Even travelling at the speed of light, the absolute speed limit of the universe, it would take 100,000 years to cross it. That number alone is staggering. 100,000 years is longer than recorded human history, longer than the rise and fall of empires, longer than agriculture, writing, science and civilization itself. And yet, this colossal structure is merely a single island in a vast cosmic ocean. Our galaxy contains somewhere between 200 and 400 billion stars. Many of them host planetary systems of their own. Our Sun is just one ordinary star among them, located about 26,000 light-years from the galactic center in a relatively quiet region known as the Orion Arm. Our solar system races around the Milky Way at roughly 500,000 miles per hour. yet it still takes about 250 million years to complete one full orbit. A period astronomers call a galactic year. To put that into perspective, dinosaurs lived and went extinct without our solar system ever completing a single galactic lap. The last time the Sun occupied a similar position in the galaxy complex life on Earth had barely begun to exist. And despite all this, the Milky Way is mostly empty. The nearest star to us, Proxima Centauri, lies over 4 light-years away. If the Sun were reduced to the size of a grain of sand, Proxima Centauri would be another grain sitting miles away with almost nothing between them. Space is not crowded, it is overwhelmingly vacant, yet somehow, across these immense distances, enough matter exists to form billions of stars. New stars are still being born today inside giant molecular clouds, while old stars quietly burn out and die. When you look up at the night sky from a dark place and see the glowing band of the Milky Way, you are witnessing the combined light of billions of distant suns. For most of human history, we believed that band of light was the entire universe. Different civilizations gave it different meanings. Ancient Greeks saw it as milk spilled from the goddess Hera. The Romans called it the Milky Road. In India, it was believed to be the path of souls travelling to the afterlife. Indigenous cultures across the world saw rivers' roads and cosmic realms written into the stars. Everything changed when telescopes revealed that this glowing band was made of individual stars. Then, in the 1920s, Edwin Hubble made a discovery that shattered humanity's understanding of reality itself. He proved that the fuzzy patches seen in telescopes were not clouds inside our galaxy, but entire galaxies far beyond it. The universe was not just the Milky Way. It was filled with galaxies, billions of them. Today, astronomers estimate that the observable universe contains roughly 2 trillion galaxies, each containing billions or even trillions of stars. And among these galaxies, there exists an extreme hierarchy. Some are small dwarfs, others are majestic spirals like our own. And at the very top sit the cosmic giants galaxies so large, they redefine what large even means. One of the most extreme examples is a galaxy known as IC 1101. At first glance, the name sounds unremarkable, but IC 1101 is anything but ordinary. It resides at the centre of the Abell 2029 galaxy cluster, deep in the direction of the constellation Virgo. From Earth, astronomers observe a massive congregation of galaxies locked together by gravity, and at the very centre of it all sits IC 1101, dominating the cluster like a cosmic emperor. IC 1101 measures between 4 and 6 million light-years across. Our Milky Way, enormous by human standards, is only about 100,000 light-years wide. That means IC 1101 is up to 60 times larger than our galaxy. If IC 1101 replaced the Milky Way, it would swallow our entire local group, the Andromeda Galaxy. Triangulum and dozens of dwarf galaxies would all exist inside its vast body. What we consider our cosmic neighbourhood would become a tiny region within this single galaxy, and its size is matched only by its population. IC 1101 contains an estimated 100 trillion stars. That's roughly 250 times more stars than the Milky Way. Counting them at 1 per second would take more than 3 million years without stopping. This galaxy was first spotted in 1790 by William Herschel as a faint blur of light. For over a century, no one understood what it truly was. Only with modern astronomy did scientists realise that the light reaching our telescopes today left IC 1101 more than 1 billion years ago, long before complex life existed on Earth. IC 1101 did not grow quietly. It grew violently. Astronomers believe it became so massive through a process known as galactic cannibalism. Over billions of years, IC 1101 absorbed at least 76 major galaxies, along with countless smaller ones. Each merger stripped stars and gas from its victims, adding them to the growing giant. These repeated collisions destroyed any spiral structure IC 1101 once had, transforming it into a massive elliptical galaxy. The chaos of these mergers mixed its stars into a smooth, featureless form, a silent record of cosmic violence. Yet despite its enormous mass, IC 1101 is slowly dying. Most of its stars are ancient. Star formation has nearly stopped. The gas needed to create new stars has been consumed or expelled. What remains is a colossal aging galaxy, magnificent, powerful, and slowly fading into darkness. At its center lies one final marvel, a supermassive black hole with a mass between 40 and 100 billion suns, one of the largest ever discovered. It dwarfs the black hole at the center of our Milky Way by tens of thousands of times. IC 1101 stands as a reminder of the universe's true scale, how small we are, how vast reality truly is, and how much remains beyond our understanding. If stories like this make you feel small, curious, and amazed all at once, then you're in the right place. If you want to keep exploring the deepest mysteries of the universe, giant galaxies, black holes, lost civilizations of the cosmos, and the questions science still cannot answer, make sure to like this video and subscribe to the channel. Your support helps us continue bringing you stories that push the limits of human understanding. And together, we'll keep looking deeper into the darkness, searching for what's still waiting to be discovered.